So this is the SLS rocket, and look at this thing clear the tower. This is just amazing. Just watch this thing go. This is the world's most powerful rocket, and I want to explain to you why it's so important in getting us back to the moon and eventually to Mars. So this is the Artemis 1 mission, part of the Artemis program, which was started back in 2017 with the main goal of establishing a long-term human presence on the surface of the moon. So what is the significance of this launch? So Artemis 1 is the first launch of the Artemis program to achieve that main goal. So Artemis 1 is an unmanned vehicle, and it's going to go around and circle the moon and basically test for the Artemis 2 mission, which will carry humans. So this is how this rocket launch is going to go. So the rocket, as you see here, is going to leave the pad, clear the tower, and it's going to go for 2 minutes boosted by those 2 white solid rocket boosters. Then after 2 minutes, those will separate, which provided around 75% of the thrust. And then the 4 RS-25 main engines will propel the whole rocket for another 6 minutes into orbit. Now, I also want to tell you that the whole thing together produces 8.8 million pounds of thrust, which is the second most amount of thrust produced by a rocket. The N-1 rocket, which was the Soviets' version of our Saturn V, which was meant to get to the moon, it never reached space. It all ended in fireballs. So this is probably going to be the first rocket that's going to be the most powerful to reach space. So after the rocket reaches orbit, the big orange section with the RS-25 engines will separate, and then we have the second stage, which is a tiny second stage with 1 booster, and then the Orion capsule on it. So those will orbit the Earth for 1 rotation, and when all the systems are checked, then it will light up, and then it will propel the Orion capsule and its service module towards the moon. So once that second stage separates, the Orion capsule will just coast towards the moon for 3 days, and then it will reach the lunar orbit. And what the moon will do is it will capture the spacecraft and put it in a type of elliptical orbit. So the spacecraft, the Orion capsule, will be in the moon's orbit for 42 days. And here's the moon. This is how it will work. The capsule will come in and it will circle the moon like this, but then go out 40,000 miles away from the moon. And then it will come back in, go out. And over a period of 42 days, it will get some close approaches to the moon, close enough to be 60 miles from the surface. And remember, the moon is 240,000 miles from the Earth. And that's how far the Orion capsule has to travel. Amazing. So once it's done its 42 days there, conducted experiments for the first crewed mission, then the tiny little engine, AJ-10 engine on the back of the service module will light up and will propel the Orion capsule towards the Earth. And once it's finished its burn, it will escape the moon's orbit, and over a period of 3 days again, it will travel at super fast speeds towards the Earth. And as it approaches the Earth, that little service section separates, the capsule will turn around and face its heat shield towards the Earth. And it will be coming in at over 30 times the speed of sound. So as soon as it hits our atmosphere, it starts heating up. And it will get as hot as half of the sun's temperature, which is unbelievable. So once it goes to the atmosphere, it will start coming down towards the ocean, deploy parachutes, and land in the ocean. And then that will conclude that mission. And then the Artemis 2 mission will learn off of the data from that, and it will be the first crewed mission to travel back to the moon. And Artemis 2 will carry the manned Orion capsule this time for 8 to 10 days. It's like the Apollo 8 mission. So, let's talk about the Artemis 1 rocket itself. So something looks a little bit familiar about this rocket. Can you tell? Well, with the orange external fuel tank and the 2 white solid rocket boosters, this rocket may resemble the space shuttle for some reason. Well, that was intentional. You see, back in 2005, NASA started the Constellation program, which had about the same goal of the Artemis program, to get back to the moon. So, the Constellation program recycled a lot of the technology used from the space shuttle. So the program was riddled with delays, going over budget, and it was a problem. But they did have one launch of a solid rocket booster as its own vehicle. But anyway, the program was canceled in 2009. But one important thing that came out of it was the Orion capsule was developed, which is what we're using today in the Artemis program. Anyway, after the Constellation program ended, a lot of people went out of jobs because they were employed to work for this program. So NASA was able to start up another program, which ended up becoming the Artemis program, with the 2010 NASA Authorization Act. So under this act, NASA was also required to make the program a little cheaper by using existing technology that they could reuse. So they decided to make like a hybrid of the Saturn V and the Space Shuttle. And they used a lot of parts left over from the Space Shuttle program. And what they came up with was a first stage made up of 2 white solid rocket boosters, which were a little bigger than the shuttle. They extended them. And then they had this big core stage. This was not an external fuel tank. It was a full rocket stage. And it had 4 RS-25 main engines that were all used on the Space Shuttle program. And then, you know, you had a proven second stage, the RL-10 upper stage. And then we had the Orion capsule, which was already developed. So they thought by reusing these shuttle parts, it would be a lot cheaper. It ended up being really expensive, and the original launch date of the Artemis 1 mission that's happening was in 2018, so we missed it by 4 years. But this rocket, even though it's made with 1970s technology, is still a very capable and amazing rocket that came out of all these delays and canceled programs. So where are we now? So this mission, the Artemis 1 mission, is part of 3 steps in getting back to the moon. So we're going to have this mission, which is the test flight, then we're going to have the Artemis 2, which is going to take humans around the moon, and then Artemis 3, which is going to be humans in the Orion capsule again, except there will be a SpaceX Starship configured to land on the moon. So then the astronauts will take the Orion capsule, dock it with the Starship, then they will land on the moon for a certain amount of time, and then they will take off and come home. But the most important part of this mission is that we're going to make a space station that's going to be in the moon's orbit. So that space station is called Gateway. And Gateway is a collaborative effort of creating our first habitable space station around the moon. It will be in a sort of elliptical orbit like I told you on the first Artemis mission. Anyway, so Gateway will be launched in segments, like the ISS was. So the Artemis rocket will take like 1 or 2 segments at a time, and they will go into the lunar orbit to wait for more. So it will require an SLS launch every time they need a new segment. But by 2028 to 2030, we should have the full Gateway constructed. So the most important part of this program is, how are we going to get to Mars and, you know, get more stuff into space and towards the moon? NASA is developing bigger and more advanced versions of their SLS rocket, starting with the Block 1B and the Block 2. The Block 2 will have over 10 million pounds of thrust to carry it, which is unbelievable, more than the N1 rocket. And the current rocket only has 8.8, so we have a long way to go. Anyway, so each of these rockets will be configured for a different purpose. One will be a cargo version, just meant to carry cargo. One might be for the Orion capsule, but to send it into deep space. This rocket has so many implications, which is why it's really awesome. But overall, these Artemis missions, Artemis 1 through 3, are the biggest part of getting back to the moon. And Artemis 1 is that first step, and it's so amazing to see it launch. Our mission is to make you space intelligent.